Hello and welcome to this lesson about setting up and solving algebraic word problems. The learning target for this video is being able to construct an equation from a word problem. So this video is definitely meant to be an introduction to more complicated algebra problems, where there's going to be an unknown thing and we're going to have to solve it perhaps in a 1, 2, or even a multi-step equation. We're not going to do any multi-step equations in this video, but we're definitely setting the stage to be able to do that later down the road. So I'm mostly going to focus on 1 and 2 step ones. Okay, what we need to focus on are two key terms here, coefficients and constants. And we need to remember what these are. So let's say we had an equation, 2x plus 8 is equal to 12. Well, our coefficient is anything that is next to a variable, so that would be a 2. And our constant would be 8 and 12. And let's just kind of, throw out some different examples. Let's put some negative signs in here. So let's now say we have like negative 3x plus 5 is equal to negative 12, or something like that. The negative 3 is our coefficient, our 5 is a constant, and negative 12 is also a constant. Now I bring this up because as we write our equations to solve a word problem, we need to think, what is a coefficient? And what is a constant? And then that leads to yet another question, which is, where do I put my variable? So as you're reading, let's be mindful of these things. Let's think about what will be a coefficient, what will be a constant, and where we'll be putting a variable. And now before we get into some examples, one final thing I do want to go over, something that we need to think about, is, do we actually answer the question? Now, more often than not, especially with the more simple and basic problems, when you solve the equation, you do answer the question. But do make sure that you actually answer the question that was posed to you. So let's look at some basic examples. So in this first one, I have John is 5 years older than his cousin. If John is 18, how old is his cousin? So what we're going to do is we're going to kind of start off with a ton of variables, or just a ton of different things. So on one side, we have John, and there's some sort of expression with John that's going to be equal to his cousin, or an expression about his cousin. And so now what we need to do is kind of sort through some of the information we have. And so let's take a look at the numbers. Are these constants or are these coefficients? And I'm thinking that both of these are constant values. John is always going to be 5 years older than his cousin. So that one's definitely constant. Now, John being 18, you could say that does change. However, I think right now we're stating he is 18. That is his current age. And so when I go to write an equation for this, John is 5 years older than his cousin. So I'm getting what? John equals his cousin's age plus 5. Okay? Now, if you're ever confused, feel free to kind of test it out with some simple numbers and see if it makes sense. So test with simple numbers. And it should make sense. So for example, if I let his cousin be 1, John is 6. Okay, that's good. If I messed it up and I wrote the other way around, let's say I got j plus 5 is equal to his cousin's age. When his cousin is 1, let's see here. When John is 1, his cousin is 6. Now that doesn't make sense because John's supposed to be older than his cousin. So forget that. So that's one way we can always kind of check, test with some simple numbers. Anywho, now that I have it, I can plug in my numbers. I don't know what the cousin's age is, but I do know that John's age is 18, and now I have an equation that I can solve, subtract 5 from both sides, and I have C is equal to 13. So this cousin is 13 years old. All right, let's look at another example. John is twice as old as his cousin. if John is 28, how old is his cousin? Okay, so here, again, we're still going to be relating John, and there's some sort of expression, that's why I'm circling it, is equal to some sort of expression of his cousin. There you go. All right, now here it's a little bit different. John is now twice as old as his cousin. So John is going to be equal to whatever his cousin's age is times 2. All right, and again, if I want to, I could double check this with some simple numbers. Another hint I have for you is that if you see is, that's an equal sign. So we'll talk more about this a little bit later, but is an equal sign. So right there I can go John is twice cousin. And I mean, it practically wrote itself. Now I just plug in the number. 28 is equal to 2c. And here, 2. John is now, the cousin is now 14 years old. All right, so different John, different cousin. Okay, so those are some basic examples. Now, let's look at something a little more complicated. The ground is currently covered by 2 inches of snow. It starts snowing at a rate of 3 inches an hour. How long until the ground is covered by 7 inches of snow? All right, now this is a great example because we have 1, 2, 3 numbers. Now, let's go back to an equation that we wrote earlier when we were kind of talking about all of this. Look at this one. This is a classic 2-step equation. There are 1, 2, 3 numbers. One of them is a coefficient. The other 2 is a constant. So odds are same thing's going to have to happen here. So what's a constant value? Or what is maybe the one that's most subject to change? Because that will be our coefficient. And the one that's most subject to change would be this guy right there. 3 inches an hour. And so what that roughly translates to is 3t, 3x, 3a, 3n, whatever variable you want to use. Now currently there's 2 inches of snow, so that's got to be a constant value. And the 3 inches is being piled on top of that 2 inches of snow, so we could say plus 2, because that's already there. And then for every hour, we're getting an additional 3 inches. And we're wondering how long until we have 7. And so there we go. We've set up the equation, and now we can subtract 2. We have 3t is equal to 5. Divide by 3, divide by 3. T is equal to, and we can just say 5/3 of an hour. That works. Finally, we have this example for you. A handyman charges $35 an hour for a project. He will dispose of any large appliances for $50. If he charged $120 for installing a new dishwasher and hauling away the old one, how long did he work? So again, we see 3 numbers, and we have to think which one is the coefficient and which ones are the constants. And so let's see here. The handyman charges a rate, $35 an hour. A rate will more often than not be your coefficient. So $35, and then it depends. If he works 1 hour, that's all he'll charge. If he works 2 hours, he'll times that by 2. If he works 3 hours, he'll times that by 3. So that's going to be our coefficient. Now, we're told in this problem that he's doing a little bit of extra work. That's a flat fee. $50, he'll take whatever large appliance and get rid of it for the client. That's a flat fee. So we're just going to add that once. And this represents, 2 components to a job. The actual labor he did, and then this little task he's doing. And when we add those together, we get the total cost, which is $120. And so from here, we have the equation. We can now solve. 35x is equal to 70, divided by 35, and x equals 2. So, 2 hours. As you're setting up these equations, just be mindful of, again, coefficients and constants. And then from there, if you're kind of stuck on something, you can try, plugging in some different numbers and seeing whether or not it works. Good luck with your homework or practice, and let me know if you have any questions.